In this example, we're going to look to square this trinomial. And so remember, when we squared a binomial, we had a nice formula that we can use. Well, there's no such formula that's really practical to use with squaring a trinomial. We'll multiply it out and we'll look at the terms, we'll kind of inspect and we'll discuss what that formula might look like, and then we'll go from there. So instead of trying to use some formula, let's just cross that squared out and we'll just write this in expanded form and just put them next to each other and then go ahead and multiply them out like we do when we multiply two trinomials. So we'll start with this 5y cubed and we'll distribute it all the way across this trinomial here. So we'll have 25y to the 6th, which is 5y cubed times 5y cubed. And then we have the 5y cubed times negative 8y, and that'll give us minus 40y to the 4th. And I'll put a little space here where the y to the 5th goes, because you never know if we're going to have a y to the 5th. And then 5y cubed times positive 3, that will give us plus 15y cubed. Okay, so we distributed that first one through. So let's go ahead and take a look at this negative 8y, and we'll distribute him through these three terms. So negative 8 times 5 is negative 40, and then y times y cubed is y to the 4th. And you'll notice, hey, we've already got one of those, and here's another. So negative 8y times negative 8y, that's going to be a perfect square, and it looks like 64y squared. And then negative 8y times 3 looks like negative 24y. And finally, let's go ahead and distribute this positive 3 through there. So 3 times 5 is 15, and then y cubed. And look, we've got one of those already. We'll just add another to it. 3 times negative 8y is negative 24y, and there's another one of those again. And 3 times 3 is a perfect square. That's going to be positive 9. Okay, so as promised, let's go ahead and kind of inspect the types of terms that we have before we just go ahead and combine these like terms. So the 25y to the 6th was a perfect square when I multiplied these firsts together. And then this 64y squared is a perfect square when I multiplied the second terms together, which were the same. And then this plus 9 is a perfect square when I multiplied these 3's together. And then you'll notice all the rest of the terms come in pairs. So we have a pair here, and a pair here. So really, if you wanted to write some kind of formula or generalize this, or maybe do it quick in your head, it's going to be if you had a plus b plus c quantity squared, you'd have the a squared and the b squared and the c squared, and then you would have, what, 2ab and maybe 2ac and then maybe 2bc and kind of like that. So, but again, that's a lot to remember, and sometimes it's easier just to multiply it out like this anyway. So let's go ahead and combine like terms now. 25y to the 6th comes down, minus 80y to the 4th, plus 30y cubed, plus 64y squared minus 48y plus 9. And this sextic polynomial in 1, 2, 3, 4, 5, 6 terms is going to be the product when I square this trinomial.